Hi folks, Dr. Cooper here, welcoming you to this introduction to the NX modeling app. We've got a lot of things to get through today, from making part files to doing some sketches, extrusions, revolutions, all kinds of stuff. This video will be time-stamped, so if you need to jump around a little bit, if you're looking for a specific part of the video, you should be able to find it pretty easily down in the description. And I've also turned on some key visualizers here, so as I'm pressing Shift, Control, all these different modifier keys that you might need, those will pop up on screen, along with my mouse clicks being annotated and being shown in real time. So, to get into modeling, we've launched NX. We're at the gateway now. We're going to go to New. It's going to take a second to think about it, and it should put you in the Model tab by default. So in the Model tab, if you've set up NX to have default units of inches, this will say inches. If you have it set in metric, this all will be a metric for you, and that's okay. But I work primarily in inches, so we're going to use that. We're going to pick what we want. So we're working with modeling again, not assemblies or Shape Studio yet. So go into Model. We're going to give this model a name. So I'll say test part.prt. If I can type. And then the folder we're going to save this to, not program data. A lot of people lose their stuff in the deep, dark depths of program data. We're going to move this over to documents, but you can use your desktop, your Google Drive. I don't really recommend that just because of syncing issues you can run into, but we're going to work with documents on the local machine here and hit OK. So, we've loaded in, and I'm going to treat this as though you've never seen NX before, as though you've never seen CAD before in general, and kind of walk you through this step by step, literally top to bottom. So at the very tippy top here, this is your quick access toolbar. So if you need to make another new file, open a file, save, this kind of works like what you see in Microsoft Office and other apps like that. This is your quick access options, undo, redo, as those are needed. Going down a little bit, we have these different tabs. So home is what we primarily work out of, or what I do at least. That's what we'll be seeing a lot of today. Surface, for more freeform surfaces, it's much more complicated. Assemblies. The cool thing about NX to me is that everything is a .prt file. So you can start with a part file, but then add other part files into it to make it into an assembly, but they all share the .prt extension. That's compared to something like SolidWorks, where it's a separate type. It's SOD ASM, I believe. So you can make your PRTs into assemblies. You just have to be careful about that and keep track of what's what. But that's for a different video. Under Tools, this is where, in my role that I've set up, you'll find things like measuring, assigning materials, expressions, VR, parameter tables. We'll talk about all that good stuff later. We won't see this too much yet. PMI we'll also see later. Don't worry too much about it. And then application would allow me to jump from modeling to drafting, for example, or manufacturing to do some CAM. But again, later down the road, nothing to worry about. If you followed my installation guide at Miami University to install NX, it comes with this role that you're seeing, this unique user interface that's a lot more slimmed down than what you start with. You can easily customize this. If you right click up here, you go to customize. You can drag and drop everything up here, make your own tabs, make your own groups. So new item, new group, for example, I can put that up there. So if you don't have access to that role, or you don't want it, or you want to make your own, that's how you would alter it. But if you're at Miami, which is where I currently am right now, you have access to this default role that's a lot more simplified than what NX would give you right off the bat. So just want to clear that up really, really quick. Continuing down, we call all of these our commands. So that's our command palette on every tab. These are the commands, again, that I use the most, that you'll probably use the most. If you hover over them, you'll get a description of what they do, but we're going to see a lot of them in action here very soon. Moving down, this bar may not show up for you. So there's no selection filter assembly menu. If it's gone, right click somewhere out here and make sure your top border bar is turned on. This is incredibly useful, and we'll see that in our sketches about what we're selecting, how we're selecting it, and it also gives you access to this menu functionality. A lot of things are available in File, but even more stuff is available in Menu that you cannot get to under File or even through some of these tabs with the commands listed on those tabs. So this menu, if you're reading some Siemens NX help on the internet, or you're looking for something and it's just not under File for you, or you're looking for like menu to tools or something like that, you're going to work in this. This is a very tricky thing for some people. It took me a long time to find that, but make sure you're aware of this little extra menu that gives you way more options than anywhere else in NX. Moving down even more, on the left side we have our navigators. So Assembly Navigator, Model-Based Design Navigator, Part Navigator. I primarily work here for modeling because we're going to see a bunch of our features come in and sketches and extrusions. So I live here, but if you need to customize this a little bit, if you right click in this gray column, you can hide things. So I can get rid of MBD, add the constraint navigator back for assemblies, that kind of stuff. But these are all your different navigator options, and you can even get like a web browser over here if you're so inclined. All right. So moving even further down in NX, I don't often find myself in these menus. They're occasionally useful to talk about details of your files, dependencies, search functionality. A lot of what I do does not rely on that, however. But if you find yourself down there, don't fret too much. It's usually pretty self-explanatory what you're looking at, how you're interacting with something. But for now, don't worry about that stuff down there. Moving into the fun part, as we scoot on over to our workspace, we have this viewfinder down in the corner. So if I hold down the middle mouse button on my little icon there, you can see I'm rotating my view. If I continue hold down that middle mouse button and right click, I start panning around. So I start sliding around our part, which we'll see in a little bit. If I need to snap to a certain view, so one of these faces, I can click on it like that, or like that to move around a little bit. If I want to fit this back in the center of the window without having to drag it over, I can hold down Control and press F, and that's fit, so it will fit to your screen. And once we have a part, it will fit the part to your screen as well, or your assembly, but it's a good way to recenter it. And if I want to get back to my more, let's say, diagonal views, that would be trimetric or isometric, the home key is going to send me to a trimetric view, and the end key is going to send me to an isometric view. So those are really nice. Like if you're all wonky and you're upside down and out of the way, if I hit either one of those, it centers it and goes to that angle, trimetric or isometric, to allow us to see the part a little bit better. We can set work views. So this happens, this is pretty useful when it comes to exporting stuff. When you try to export a DXF, for example, like a 2D pattern, it's going to ask you if you possibly want to use the work view to export. So right now it would try to export a DXF projection of my part in the trimetric view, but I can set it to the top, right, left, isometric. It doesn't change the functionality of home and end. Like I still get the same views no matter what my work is, but it defaults to trimetric. Just wanted to point that out as we're talking about views, because it is useful to change this every now and then so you can do a little bit quicker exporting out of NX for stuff like DXFs, some manufacturing related stuff, and other good stuff like that. Okay, so that's the interface of NX. We haven't done anything yet. We've learned how to rotate, pan. You can zoom by scrolling in, but that's pretty intuitive. Modify your view, all that good stuff. So let's start making something. So the first thing we always do in CAD of all kinds is we're going to start with a sketch. You can import that sometimes if you have a drawing that's pre-made, But in our case, and in my experience, the vast majority of cases, we're starting from scratch. So we're going to start by making a sketch. I want to take a quick second to look at these NX menus. So you have dialog options here in the upper left corner. I really don't use this menu too much. It's for saving favorites and collapsing dialogues and resetting. But if we move over, if we do want to reset it quicker, we can reset this whole dialog box and all of its options with the reset button. If we click on help, it will pull up a help menu on the left side with some live tutorials and videos that are narrated that are pretty helpful for a lot of this stuff. And then of course we can close this menu at any time if we so chose. Moving down, boxes like this often dictate some type of category. So it's asking if we want to make a sketch on a plane or on a path. On plane is the more common option if you ask me, so we'll stick with on plane. If you go to show shortcuts in NX anywhere, it's going to give you this button type menu that some people prefer. But if you would rather have a drop down, you can hide those shortcuts and have the drop down instead. So here we get to our first box. It says sketch plane. It says show principal planes, and that's these big front, right, top, the three principal planes of our part. And it tells us to pick a sketch face or plane. So I'm going to pick the front plane for now. So I would just hover on the edge of this. If you hover in the middle, it doesn't really do anything, and clicking doesn't do anything. But hovering on the edge is going to let me pick that plane to start a sketch on. When we look at this coordinate system, we can flip the normal vector. So the normal vector, as you probably recall, was pointing outwards from the surface normal. So if we flip that around, the blue normal vector is pointing away, and that's showing that that's Z positive essentially in blue, with X and Y in red and green respectively. But I like that facing me. It kind of fits the coordinate system that's pre-established by this text, so I want to keep it there. And then something you'll see across all of NX are these little tiny menus. And when you drop these down, this kind of gives you advanced mode for these things. If you keep these collapsed, you can get through a lot of stuff, but there's some functionality that you'll never see unless you open these menus and you start working with the more advanced options. So this is asking for orientation, specifically horizontal orientation. And so we can see that when we flip it, we're essentially flipping the directions of the X and Y vectors now instead of the Z vector like that. So we're not messing with the normal, but we're messing with the kind of rotational orientation of this coordinate system. But we're going to leave everything as is for now. It was pretty good to start with. We picked it pretty well. We don't really need to use that if we don't want, but I'm going to keep it open for the future, and we're going to hit OK. And we can either click, or the cool thing, if you ask me, is I can just middle click, and it'll automatically pick whatever button is blue down there in the bottom. So middle click, accepts it with OK. I'm going to close this web browser so it's not distracting. And then we're in a sketch. So we are working in this sketch plane. If I rotate, you can kind of see where our plane is. It's a little bit, of a perspective challenge to keep track of exactly where we are. But we like to work in 2D, so we're going to draw something on this 2D plane right now. You have clearly a ton of options in Sketch. It is an overwhelming number of options for a lot of people. But let's start with the most simple but free-form thing. That's a profile. So a profile is just a series of connected line segments. You can do arcs too, but I'm just going to do like a simple polygon type shape to start us off here. And I do highly recommend you follow along. You don't need to make the same shapes that I do and do the same stuff that I do, but I highly recommend that you do something to participate and have something of your own to show off and play with in NX as we go through this. That's why I'm making YouTube videos instead of teaching this in lecture, because I found out the hard way that sucks. Anyhow, when you pick one of these buttons, it'll pop up a little menu like this, and we have discussed what these symbols mean up here. But it allows you to pick a line or an arc. I'm going to stick with a line. And then with a profile, you can just start plopping down your basic shape. So the shape that I'm going to make is pointy on this side. It's going to come down. It's going to come over, go up, and then back down. And you saw as you're sketching, it's trying to make some alignments. So this is saying this is going straight up. This is parallel to the other thing it's highlighted just for your reference, so you can, get it close on this first pass. And show some alignments. So the dashed line there horizontally is showing that it's aligned with the midpoint of that diagonal. It's aligned with the midpoint of this down here. So there's lots going on, but I'm going to kind of cut through the noise a little bit. I'm going to close this shape. That's close to what I want. And then I'm going to hit escape once to stop drawing, and then escape one more time to finish the drawing tool and get a shape close to what I want to start with. All right, I turned nightlight off because things were turning orange, but back to business. All right, so we have this basic shape here. I just sketched something that was close to what I wanted. I could have done rectangles and gotten fancy with triangles and lines, but a lot of the time you just sketch out the basic shape you want with the profile tool, and then we're about to go in and make sure that this is exactly what we want it to be in terms of angles and in terms of distances. So the first thing I want to do is align the center of this line on the bottom with this point right here in the middle. This is kind of our global coordinate system 0 point, and so to me it's kind of silly to not center this right here. It's just kind of like a perfect match if we were to do that. So what we do to create a relation, we're going to make those 2 points coincident, and that's this tool right here, is the make coincident tool. So what I like to do is I'm going to pick the line first, because picking the line allows me to select its center point. And you see that once I pick that center point, it no longer has selected the line. So that was kind of just like opening the door to make sure I can reach that center point, and then closing the door again so I don't have that line selected. From there, I'm going to pick that origin, and instead of messing with these dimensions yet, which we could possibly do, I'm going to pick these two things and just say, make these two coincident. And that will snap them and glue them together until I tell NX that they should no longer be coincident. So those two things are stuck on each other forevermore until I say otherwise. The next thing I want to do is I want to make this 90-degree angle. It looks close. It could be 90 degrees already, but we don't know that for sure, so I need to constrain it to be 90 degrees. And there's two ways we can do this. Like I said with this point, I can either do a relation, because we do have this perpendicular relation, or a dimension. I can force it to be 90 degrees. So let's do both. So I'll do over here, I'll pick these two lines. They do happen to be 90 degrees, so let me mess that up really quick. Make them real bad. So there's 15 degrees. If I pick these two again, and I say these must be perpendicular. Oops. I gotta get rid of this now. If I say these must be perpendicular, it makes them perpendicular. And it didn't let me do it the first time because I had put in a constraint that they would be 15 degrees, and perpendicular is not 15 degrees, so there was a conflict there. But now, through the use of a relation, I have made these two things perpendicular to one another. On this side, let's say we also want 90 degrees. Let's do that with an angle constraint. So when you click two lines, it will give you possible relations between them or possible dimensions between them. And in this case, the only dimension possible between these two lines is an angle. And so in green, it is saying, hey, just a heads up, these are about 84.6 degrees, just to let you know. But if I click away, it goes away. It's not persistent unless I do something about it to basically confirm with NX that I've manipulated that and I've locked it in, so it's good to go. So let's click on these two lines again. And if I click on this dimension once, it pops up this menu where I can either type in the angle. So let me type in 60 degrees, and it will go to 60 degrees. Or you can actually click and drag a lot of stuff in NX. It's really nice to have that creative liberty to say, let me see what 70 looks like. Let's try like 101. So you can click and drag this a little bit and play with it, get it close, and then let's say at the end of the day, you're like, nah, let's just do 90. I don't want to click and drag to find it. You can go back to that box, type, hit enter, and now when I click away, that stays persistent. If you can see it, it is a persistent dimension. It's not going to go away when you click on the screen. So those two lines are also locked to be 90 degrees apart from each other, which is just like the perpendicular constraint on the other side. The other type of dimension you'll primarily work with is a linear distance dimension. So in that case, when I click a line, as you've seen so far, I do get a dimension spat out at me. So again, same rules. It's in light green. It's like, hey, heads up, this is about 3.8 inches as a reference. But if I click on this, I say, let's make this 5 inches. It will say, I'm editing the first dimension of the sketch. Do I want to scale the entire sketch? 99% of the time, hit yes, because it will take this shape and preserve the basic angles of the shape and just kind of blow it up so that that bottom line is 5 inches long. This is like a scaling operation right now. So I'm gonna click yes. The whole thing scaled up, but it retained all of the relative angles that haven't yet been constrained. And then we have a 5-inch long base on this sketch. So when we look at this, we see two different colors going on now. We see a black line and a bunch of brown lines, along with this blue infill. A black line is fully constrained, meaning that if I grab this and I try to grab the endpoints, it shouldn't move. Like if I grab the line itself, it won't move unless I really yank on it, because NX will sometimes say, okay, I'll let you move it. But this is fully defined, essentially, that the center point is locked onto this point right here in the middle. We drew it horizontal on this line, so there's a constraint from our original profiling that it has to fall along this, so it's locked there. And we know the length of the line is 5 inches. So that is a fully defined line. But if I come up here, like I grab the intersection of these two brown lines, there is way more play in these. So I can grab this one. I can shrink things down. I don't have to like really shake it to kind of let NX let go of it, so to speak. That these are not fully defined lines, and so they're brown. And not fully defined sketches are the enemy in CAD. We always want to fully define everything, because when we take this and we hand it to the manufacturing people and they say, how long is this, or how big is this dimension, you can't just stand there and shrug your shoulders and say, I don't know. So we need to go through and fully dimension this part and constrain these angles and lengths to get a more fully defined product that can then be manufactured and inspected and delivered to the customer. So what I want to do is I'm going to set the length of this upright first. I'm going to say the length of this upright should be 4 inches long. We know how to do that. And let's say we want this to be symmetric. Like we want the other upright to also be 4 inches long. You can click on both and use the equal constraint, the make equal constraint, and that will snap the length of this to be equal to the length of that. So you only need to define this one. And if you go back and I say, let's make this 3, it will shrink the other one at the same time because they're forced to be equal to each other. So these relational modeling techniques are really, really handy because you can get away with doing one length and just mirroring it across, doing minimal typing to get maximal geometric constraints. So it's more of a philosophical thing. Some people will dimension this whole thing. Other people will use lots of relational constraints like that. That's kind of how I am. But find a system that works for you. Just make sure that all of these lines will eventually be black because they're then fully defined sketches. The whole sketch is defined. So let's set this angle really quick. We'll set this angle to 60 degrees. Let's say we want to do another equality constraint, but we can't directly get this angle. We can set that the lengths of these two have to be equal. So now we have a fully defined sketch that if the lengths of these two are equal and the lengths of the outer two are equal, this angle has to be the same here and here, and then this angle has to be symmetric around that center line. If you don't believe me, do the trig. I promise you that's how this works, because we have equal length hypotenuse, hypotenuses and equal length uprights on these triangles. So we have a part that's symmetric about this green center line. Everything is constrained. There is no geometric ambiguity in this anymore, and we've achieved a fully defined part. So before we leave this sketch, we're going to do a few more things. The first thing is notice how this shaded region is blue. Blue shaded regions are your best friend because that means the whole thing is closed. So for example, if I make a profile, just real quick, I'm going to get real close but not quite touch. That is not closed. There is no blue shading here. So when we go to try to extrude this into a solid object, NX is going to freak out. It's going to say, hey buddy, I can only make this out of sheet metal. You cannot have this be like a solid chunk of aluminum or steel. There's no way this can be a solid object, sorry, because it's not closed. So if you don't have a closed region, you have a few options. One option is if you pick the two endpoints of your lines and you make them coincident, it will close the shape. Sometimes it will drag around your geometry, so you might have to go back and tweak some angles and lengths to get it right again. But that's one way. The other thing you can do is if you go up to the extend command, it says curve to extend. You just pick this curve. It's not going the right way. There we go. It will extend it down until it hits the next line. So up here, it was trying to extend this way because I was closer to the top edge of this line than the bottom. So we got this. But if you click towards the bottom of the line, it extends it downwards instead of up. So let's say we goofed. We don't want this anymore. We can go over to trim. And if I click and drag, it's kind of like a hot knife through butter. Whatever this hits, that line gets deleted out of existence. Just bloop, gone. I can always do Control Z to kind of back up a little bit if I make a mistake. But the trim tool is really handy for doing stuff like that. So that's just an example of a shape. Let's say I want to delete this. It's really simple. I'll go over here, select all of it. I'll press delete. And then that shape is now gone. We got a few more things to show off in sketches, just for some of the more basic stuff. So one thing that can be really helpful is putting in points. Points are a great way to highlight, let's say, the center point of curves. So I can do the center of these. I can do the center of that if I needed to. Points can also be put out in space and dimension too. So if we know there's a set distance from, let's say, this sidewall to a hole that we're going to put in later, and same from here to here, we can just plunk a point down if we click. Since this is not fully constrained, this is very draggable. So I can grab this, and let's say I want to snap it on to the center point of that line. I can do that really easily, but now it is fully defined because it's constrained onto that center point right there. One thing I find exceptionally annoying sometimes is if I put a point on a corner, getting a hold of that point can be really hard. Because let's say I pick one of these lines first, I'm trying to pick the end point of the line instead of the point. There's a few different things we can do, and this applies to all kinds of sketch geometry. I can click and drag, that box will only pick what is fully inside that box. So I didn't pick up any of these lines right here because it's not getting the full thing. But If I want the point and the line, I can draw a box big enough around both of them to pick up and select both. And let's say I want to delete it, I just hit delete and they're both gone. The other thing we can do to get a little bit more selection granularity is go up to our selection filter tool and pick point. So when I pick point, the only thing that will show up for me are points, but I can't pick these curves at all. Like click and drag does nothing. I'm only picking points right now. But if I need a curve, I can switch to curves, pick that as well, maybe add this one while we're at it. And now I have this set comprised of a point and 2 lines that I can, for example, delete or even copy paste, which is a really cool feature in Sketches as well. So you might be asking, how do I deselect? You might have drawn stuff already or clicked on something and you're confused and maybe hitting escape to get out of there. To deselect things in NX, you hold shift, and as you hold shift, you click the thing that's selected and it deselects. If you've been fighting with it a little bit, welcome. That was your NX initiation. We've all done it at least once or twice. But yes, to deselect things in NX, bodies, lines, sketches, features, all kinds of stuff, you just shift, click, and it's undone. A few more things as we're going through this menu. Obviously, circles, arcs, splines, points. We'll get to all that stuff here in a little bit. You can do fillets. So let's say I want to fillet this corner. It wants me to set a radius, let's say 0.25 inches, and then it will fillet your sketch so that you're not going into the part and filleting later, which we can do and we'll show that, but you can actually round off your sketch now if you would like to do that. And again, you have these fillet options here to set trim, untrim, that kinds of stuff. Control Z to undo that. For chamfering, exact same thing. I can pick this corner, or I can pick the 2 adjacent lines. I drag the chamfer back, let's say 1 inch, and then it's going to chop my sketch down to respect that chamfer that I want to put on there. This is how to edit the sketch directly. There is a way to just model this guy and then go in and fillet and chamfer stuff later once you have a solid body extruded. But there are, again, philosophical differences here. Some people like to have filleted or chamfered sketches. Other people like to fillet or chamfer their solid bodies. I like to fillet and chamfer solid bodies, so I'm not messing with sketches too often. But again, it depends on the application, the philosophy of the programmer, the user at the time. So it's really up to you, but find a system that works for you and stick with it. So we've seen most of these tools up here. We can do offset curves. Again, I hope some of these are self-explanatory. So it's a bigger, bulkier menu, but I can say like minus 0.5 inches brings it into, or plus 0.5 inches brings it out. And then when I hit OK, we get a solid line. So if you need an offset, let's say we're trying to make like just this shell-shaped thing, we don't want the inside, we'd probably want to come in and do something like this potentially. But explore these menus a little bit. They're a little scary, but again, these help menus are pretty helpful when it comes to understanding a lot of these tools and the parameters associated with them. So feel free to experiment with that as you need to. I'll point out in NX, a lot of the times there are these lists, list menus that will pop up, and that will show either different primitives like lines and things being kind of like listed together to be offset in our case. So this is a chain, so it's chained all these curves together to get this offset curve. I can get rid of that, but it's really just looking for a single chain, so it's going to keep that object in the list. That can get a little tedious, so don't worry too much when you see this list menu. It is more rare that you'll go in here than you might think, so I'm not too worried about it. I'm more worried about these more interesting features down here that will drastically change how some of these features work. So let's get out of that. I'm going to Control Z to undo that offset. We can move curves. So if we need to move this over in space, If I want to pick the curves, all the curves. So you can set the new origin point. You can drag it around in space. There's all kinds of good stuff you can do in the sketch menu. And it's my opinion that a lot of this is self-explanatory once you know how to use NX. So just please use this as you wish. Experiment with this how you wish. And get comfortable with these sketching tools that you have at your disposal. But we'll be back. We'll be back to the sketch menu here in a bit. All right, so we're done with the sketch. That's a lot of info. There's a lot of different things going on about what to do in this menu, but I hope you did find that useful. But now we're going to finish our sketch and go back to our trimetric view. I have set up a save changes reminder. I've had NX open for a very long time without saving my work. So I'm going to say yes, save all now. And that's just a reminder you can set up under, like I believe it's File, Utilities, Customer Defaults. So if you want autosave, you can go in here. But again, if you're at the university and you followed my guide, you've seen this already. So I won't spend too much time there. All right. Let's extrude something. So the best way to extrude a sketch, in my humble opinion, is to grab the sketch here, so the whole thing has been selected, and then click extrude. Because when you pre-select something, instead of having to go to extrude and click this and select all your curves again, it's pre-selected. Like you're saying, I want to extrude this, so let's extrude it. If we don't do that, if I go up to extrude, it's going to ask me to select curve. So whenever you see a red asterisk, that's saying, hey, I need information. Like this has to be given to me, like a mandatory question on a Google form. You have to give me information in order for this operation to work. So ignore that. We'll get back to that in a second. So when you click on these boxes, it will let you pick what information it's asking for. And so in this case, we can pick our curves in several different ways according to this menu. So if I pick single curve, I'm going to have to pick one curve at a time, and I get these errors at the end where the geometry just disappears. But if I go all the way around, it will eventually give me a solid object. If I do shift and I draw a box around it, it will deselect everything to show you the next thing. I can say connected curves. So I start with one, but it looks at everything else it's connected to, and then it selects all them for me, and it makes a solid body that way. Tangent curves. Let's say you have a lot of polygonal geometry, something where selecting tangential curves is important. That's an option. Feature curves, face edges, which we'll see in a little bit, sheet edges, but I like to use region boundary curves. If you come from SolidWorks or even Inventor, this should be very familiar because region boundary curves looked for closed regions like we talked about earlier. And when I hover in that region, it will select it for me. That is very intuitive to a lot of you coming from SolidWorks and Inventor, and very non-intuitive to a lot of people not coming from SolidWorks and Inventor. So use whatever is best for you. So we've given it the curve. It was asking us to specify a vector, like an extrusion vector. And once we pick this geometry, by default, the vector it picks for us comes perpendicular out of this. So it is that blue vector, and tan vector, I guess, once it flips. But we can flip it back and forth on the extrusion direction. Or if we have some goofy oblique part we need to make, we can go into the vector dialog, and this is true for a lot of these boxes. These little icons do additional stuff. I can go into this vector dialog. Right now it's set to face or plane normal, so that's how we get the perpendicular because it's coming straight out of the plane. That's what a normal vector is. You have a ton of options in these menus. They all do very different things, and they're all extremely useful depending on your application. But for now, I'm just going to say 2 points. It says, what's my first from point? So when I click on this, I can say my from point is down here. And then it says specify a to point. But just like how we got here, I can go into a point dialog. And again, it's getting a little recursive. There's a lot of different ways you can specify the point you want the extrusion to go towards. I know we're very deep in menus. That is okay. You don't need to do this all the time, but I just want to show you that if you need some very specific, very exact point selection method, there are very huge, it's a very huge variety of ways of doing that. So I'm going to get out of there. And when you see this lightning bolt, it's trying to infer your point. So I can say, let's extrude this direction, which doesn't work because it's trying to extrude through itself. But the lightning bolt allowed me to snap onto that point. It's inferring that that's where I want to go. So when you see these little icons pop up, that's kind of like an inference point that you're welcome to click on if that suits your application. Otherwise, let's say I click way off in the middle of space, it's just going to put a point down. It's just going to say, okay, we'll extrude that direction. And I hit OK. And you can see that we now have a very oblique extruded part. It is not extruded perpendicular to the sketch plane anymore. This is more rare, I'll be fully honest. Extruding at an oblique angle causes geometric headaches immediately, as you might see. But if you got to do it, you got to do it. So that is how you get oblique extrusions. One way, there are several other ways. But let's go back into our specify vector box here. And instead of doing vector dialog, there's kind of like a quick way of getting to those points here. So instead of going in there with the drop down, yada, 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 I can go down here, repick the face or plane normal. And when I click on the sketch one more time, it will figure out the normal vector for that sketch. And then we have an orthogonal extrusion once more. Working through this is incredibly important when you use NX, how you extrude it. So in the limits category, I'll collapse these to focus. In the limits category, the start is basically where's its extrusion starting, where 0 is where the sketch is. So if I say I want to start from -1, it shoves it 1 inch backwards behind where the sketch starts, and the extrusion starts there. That's if we're in a raw value. So I can type in -0.25, same thing. I can do 0.25 positive, same thing. I can click and drag this little blue dot, and I can get different start values. And so we're making it thinner by starting the extrusion later along that line. There's symmetric value. So this changes this whole menu, but it says that this extrusion should be symmetric about that center point, and it specifies the total width of the extrusion on either side of the sketch plane. So I'm going to go back to value. I'm going to start at 0, which is pretty typical. And then for end, it works the exact same way. So I can say I want to end 3 inches away from the start. But something interesting in NX that took me a very long time to understand is that that is working in an absolute coordinate system. So if I go here and I start it 2 inches away, it will still end 3 inches away from the sketch because that is the absolute coordinate. That is +3, that is +2. I'm starting at +2, I'm ending at +3. So it must start and stop right there. You might have seen there is value from start limit. And that will make this actually 3 inches. That is a now relative coordinate versus before when it was in absolute or global coordinates. So now I can make this -2 inches and the whole thing travels. Because we're saying start at -2, but the part still has to be 3 inches thick. As opposed to when we go to just value, it has to end at +3. So value is absolute. It must end at +3 wherever this start is, no matter where it goes. But if we go value from start limit, now the start limit sets exactly where this part is. Because the part is set to be 3 inches thick, so the start limit determines where it is along this y-axis we're extruding out of. There are other options with these nice tooltips to say like until selected. So until selected would extrude this shape up until another extruded body. So you can kind of merge things together. There's until extended. So if your part should go up to a certain plane, but that plane ends before it intersects with your extrusion, you can do until extended. That's a great option. Offset from selected, again, that requires picking a plane and then you extrude beyond that plane in either direction. These are interesting by use case. Once again, typically you'll do a lot of value and value from start, but until selected and until extended are both very valuable if you're trying to make everything have a common ending point. Like if you're trying to merge, say, a table leg up into a table, you only need to extrude it until the bottom of the table, and that's the thing you would select, for example. So again, more use case dependent. Don't be afraid of these. These are really, really, really nice if you ask me, but since we only have one body right now, they're a little tough to show. So I'm going to say value from start limit. So I know that this part is 3 inches thick. We're going to start at 0, right on the sketch, and extrude 3 inches away from that. Moving down this menu, booleans. What booleans do is we'll either add parts together, subtract parts out, keep only the intersection of those parts, like the mathematical intersection, or in our case, because there is nothing else in this file, it would be none. It's just going to make a body. It's not going to join it to any other body. It's not going to subtract it from any other body. It would just make a body. Inferred is like 50-50 whether it gets this right in more complicated parts. So typically I like to go in and specify exactly what I want to do. So I'll say I want none because I need to get my initial body made. Draft, this is to add taper. So I'm going to play with this angle here, but as I add a draft angle, as you can see from the front, it is tapering the front of the extrusion in. This is really useful for making molds or other things that need kind of a contour, but this is typically really hard to manufacture, so I would say use this very sparingly. Offsets can make it larger. So it is doing the extrusion, but it's offsetting it outside the boundary, outside the perimeter of our original shape. So this is kind of like the offset curves we talked about. I don't see myself using this very often, but it's there if you need it. And then for your body type, like I said, we want a solid body, but if we did not close this shape, it would be forced to be a sheet metal shape, at which point we'd have to specify how thick it is, etc., and we'd have to make this out of sheet metal. But I want a solid body because we have a closed shape. We put in all that hard work to make sure it was closed and dimensioned, and we will hit OK. So we have made our first solid body. Huzzah. So at this point, I like to hide my sketch. I think this is really ugly. It gets really cumbersome and gross. So I'll go over to our part navigator, and if you click on this eyeball, it makes the thing you clicked next to disappear. So if I want to hide this datum coordinate system, I can hide that too, and then I get a nice clean part. You can also go up to show and hide if you use my role, or you can search for it over here in the commands search window. If I want to see all my sketches, it will show all. Let's say you have 50,000 sketches in here. I don't want to see all those. I'm going to hide all of them. I can do hide all. I can show coordinate systems, I can hide them, show points, hide points, all kinds of stuff. That's all in show hide, so you don't have to click a million times through here. And so we have a solid body, and we're ready to do more stuff to it. So what I'm going to show you next is something I do not recommend doing. It's something people do, And it's something I don't like that people do in NX because it really squanders a lot of this program's potential. But I'm going to show you what not to do as long as you promise to not do it. So let's say I want to extrude something on this face. Let's say I want to put a hole in that face or put on like a peg or something sticking out of this solid body. So I need to make another sketch. What we did before is we went to sketch and we picked the front plane and we made our sketch. And here, what I like to do, what you should do, is just make a sketch on this face. And when we go in, we have all this face available. We could come in here, blah, blah, blah. I'll talk about this in a second. And I finish, and then my sketch is over here in the tree. Great. That's what you should do. What you should not do is go straight to extrude, click on this button that says sketch section, and do it this way. Because when I do this, come in here, let me put a rectangle in, yada yada, I hit finish, and let me very quickly extrude this. That looks goofy, but that's even better. This sketch is gone. One absolutely amazing thing that I love about NX is that sketches are not consumed by extrusions. As in, when I reference this sketch to make this extruded part, the sketch stays usable. It stays visible. It stays as a utility for me. I didn't put a bunch of time into a sketch just for it to be wasted by a single extrusion. But when you do it that wrong way, that sketch gets eaten up by the extrusion in this tree, and I can't directly see it. I do not like this approach. You are welcome to do that if you so choose. However, my strong advice is to not do it that way, to have separate sketches from your extrusions, and although you'll have a denser part navigator, you will have an easier time accessing the geometry that defines your part and reusing this again later if you need to make other features that look like that or that are based on that. So that is my personal approach, spicy personal opinion, but do not make a sketch through the extrude menu, because when you do the extrusion, the sketch will disappear forever. Not forever, but it won't be usable. So let's do this the correct way. We're going to put on a couple features on the front of this part. We're going to go to sketch. We're going to go on plane because we're not on path. There's no path of interest here. We're going to go on plane, and we're going to pick that front face again. It says specify origin. Some people would rather have the origin down here, let's say. So I can specify the origin point as being in this bottom corner. It usually gets messy when you start playing with these options, but some people do. At this point, I'm just going to hit OK. My sketch origin is bottom left corner of this now, and I can start bringing geometry onto this part. Now, a few things. Let's say I want to reference this part. Like, I can select it, but I can't dimension off of that. It's really not easy to work with right now. The best way to get reference geometry, so geometry that's not extrudable, but you can measure from and put dimensions from, is go up to include. And in my role, I've labeled this as construction, because this will give you construction lines, reference geometry. And it says objects to include. So let's say I want to grab this and this and this. Let's just do the whole thing. So I want to bring all of that in. So now I have these lines that do not exist outside of the sketch, like they're totally gone. But inside the sketch, I can, let's put down a circle really quick. I can come in here and I can measure off of this. So I can get distances off of this as a reference. And now, when I finish, the circle stays, and I have a dimension to it, so I can customize where it is. But all of those dashed lines, construction lines, are gone, which is great. I don't want them cluttering up my overall model view. So I'm going to double click to get back in. And let's put this circle down here for now. And what I want to do is, let's say I want 1 inch from the left side to the center of the circle. So I'm going to pick the left side, Just like before with the profile, I'm going to try to pick two entities and then put a dimension between them, just like the 90-degree angle. And the angle's up here. So I'm going to pick this entity, this upright, as a construction line. And then for the circle, if I just click on the circle, it's going to give me like the shortest distance possible. It's going to give me a distance from the edge of the circle to that construction line, which is not necessarily what I want, because I want the center of the circle to be 1 inch away from that construction line, not the edge. So this is not the dimension I want, and I'm going to press escape to get out of there. And if it sticks around, you can click it, you hit delete, and it's gone. But I'm going to pick that construction line again, hover on the circle, and then grab the circle center to give me the dimension that I actually want. It goes to the center of the circle, not the very edge. I'm going to put 1 inch. Bada boom, bada bing, we're in business. Same thing, click there, click down there, make this 1 inch, and we're good. So the last thing to make this fully defined, because it is a brown line instead of a black line, is we're going to set the diameter. That's just clicking on it typically. You can click and drag this as you need. And I'm going to set that diameter to 0.75 inches. And then we can do whatever we want with this. We can make it an extrusion that sticks out. We can make this a hole. All kinds of stuff will happen with that. Something else I'm interested in would be a polygon. A lot of people in CAD will trace their own polygons, and that's really annoying. So you can go over to the polygon tool, which is under more, which has, conics and ellipse and polygons and curve fit. But I want to pick a polygon. I'm going to put it at an arbitrary point here in a second. Let's make a heptagon. So let's do 7 sides. There's different ways of specifying the size. So inscribed, circumscribed. Let's do a radius of 0.5 inches on that circumscribed radius. 90-degree rotation. And let's just put this down and see what it looks like. That looks good. The 90-degree rotation is highlighted there. You can see it changing as I rotate around. So let's lock that in at 90 by typing it in. Hit enter. And then it gives you this dimension, which again is that 0.5 radius to the circumscribed radius that we specified. Close that. All of this geometry is constrained and locked relative to each other to stay a heptagon. So all I need to do is specify the location of the center point. Let's do 1 inch and 1 inch. And there we go. We have a fully constrained heptagon. Easy. Didn't have to draw this all ourselves. Just use the tools available to you. And then this is all fully constrained, so we can start doing work on the part with these. All right. So let's extrude these, but make them holes instead of making them like posts that stick out. So I'm going to go ahead, grab the sketch again. I'm going to do an extrude. We want to specify a vector, and it's trying to do face plane normal. So it wants you to pick a plane to be normal from. So we can click on that plane. Since we're doing a hole, we want to go all the way through on this one. So let's say we don't want to go halfway, so we can go down here. We'd say subtract, and it freaks out because it's going the wrong way. But let's make it go the right way. You can drag this and you can set some distance here. So if you want those two extruded cuts to be 1.5 inches deep, you can do it that way. But if you know they need to go all the way through this solid body, you can just say through all, and it does the math for you. It gets rid of this box, and you go all the way through the solid body. I like to go up here to the start and also say through all, so then there's no way I can goof this up here. That it will go through all on both directions and not leave me with like one closed end by accident. When you start doing drafts and offsets here, it will put tapers in these. So if you need this to be conical, that's one way of doing it, is by putting a draft. It doesn't let me do it here, I believe because of having two separate shapes. But if you just extrude the circle, you can make it conical if you want. You can offset it. We saw that stuff a little bit earlier. So hit OK. We're going to hide that. And then we have our workpiece with a heptagonal channel, a circular channel, and then an otherwise V-shaped extrusion profile. We're going to clean this up a little bit because it looks real funky right now, very pointy and jagged. And what I like to do, as everyone does when they get into CAD, is edge blends, also called fillets in a lot of other software. So an edge blend is just going to round these edges, and you can pick pretty much any edge you want. So I just want to round these over. Let's make it like a 0.1, nice beefy round, 0.2 even. Round those over nice and smooth. And if I hit OK, I get this really nice smooth geometry. Let's chamfer the uprights a little bit. So like these corners right here. So I'm going to chamfer that to 0.05. If you click on select predicted objects, that's everything in the blue. So it would pick everything for you. It's pretty aggressive. I don't really want all those objects. So I'm just going to pick the ones that I do want. On those uprights right there, hit OK. And then I have some nice chamfered corners. Looks a little bit funky. That's okay. We're just playing around. So to clean that up with edge blends and chamfers, we can apply draft out here. You can unite two bodies together if they weren't united before. You can subtract one body from another out here. So let's say we extruded these as solids and we press none. So you had like a circular peg and a heptagonal peg just merged into this, like clipping into this. If I did the subtract tool, I can say the target is the block and then the tool is the thing being used to cut through it. So you can imagine taking one part and kind of overlapping it with another and subtracting the two out to get like a mold or a set of jaws or something. There's lots of stuff you can do outside of just extrusions to work with solid bodies directly, but those tools are pretty simple because you specify the target body and the tool being used to cut it, and it removes the tool from the target. So as we look at this, we might be interested in making this a little bigger. Like maybe we need to scale this up for a part family or something like that. Really, really easy. We just scale body, we pick that solid body, and then we set our scale factor to, let's say, 1.5. It's uniform scaling. There are ways to do non-uniform scaling up here. So non-uniform means I can stretch this out this way, Y direction, Z direction. So I could do a different scale factor in every direction. But for now, let's just do a uniform scale of 1.5. So let's say we're modeling, things are good. And then you realize, ooh, I goofed up. Or like, what did this look like a second ago before I did that scale? In this menu, in your part navigator, you see this little icon floating around. And this icon is basically your spot in time. This software can be used as a rollback system, and rollback is just going back in time and kind of removing features before they were added. It's not undo, because undo is like, completely remove what I did. Rollback is keeping what I did, but I can roll back to previous states of this part piece by piece until I have nothing. So this is really useful if you got, a little lost, a little too deep in modeling. You need to go back and see how something was. Maybe something broke. Maybe you realized something. If you need to go back to a previous state in this part's lifetime, according to this tree, you just click up and down, and it'll give you that stage in the modeling process. It's a very, very handy tool, very commonly used across all CAD softwares, and something that you should really get used to using. All right, We're going to do one last thing in this tutorial. We're going to revolve this. We're going to make this into a big, large ring through a revolution about an axis. And we're going to do it by making a new plane. So basically what we want to do, if we look at this from above, is we have our part here, and we basically want to spin this around a circle, kind of like a big donut, extrude it in a circle, to get a radially symmetric part. To make this big circular part with this V channel on top and these two hidden tubes through it. So we need to put an axis of revolution where my mouse right now is. So we need to specify a straight vertical line out here, right in the center of this part, and then use the revolve command to send this around in a circle about that axis. So to get that line, and to make sure that that line is actually on the center of this part, not on the front or back face, we're going to make a new plane. In NX, it's called a datum plane. Coming from other CAD softwares, I believe it's just called plane. It's really simple. But if we click on datum plane, this is another menu with many options, many wonderful options, and these are very, very useful when you're in a pinch and you need to come up with something clever. There's at distance, so this is the default option. If you do at distance, you just click on a planar object, and then you say how far away is my plane from that object, so you get a plane directly out away from it. Something that I really, really like to use, though, is called a bisector. So when it asks for your first plane, I want the front. When it asks for your second plane, I'm going to pick the back. And then my plane that it makes is right in between the two. And just like before with the sketches, if I goofed up, if I don't want this back face, if I hold Shift and I click, it deselects whatever object I'm currently working on. So first planar object, get rid of it, but I can reselect it, move to the second planar, reselect it, and then get that plane that I want. Really importantly, you can flip plane orientation. It just really defines on what side your sketch is going to show up on. It's kind of a matter of preference a lot of the time, but I like to have it kind of agreeing with the rest of the part, like once I get a feel for it. Offsets, settings, I don't play with that too much. But one thing I do, because this is really tight around the part, is you can just extend this. There is no limitation to like that plane size. It's just a matter of how big do you want it to be, how cumbersome do you want it to be kind of in your design space. But it does not have to be shrink wrapped around your part. You can make this any size you want. You can squish it. You can downsize it. So let me do this because we want a plane out here somewhere. And then we'll hit OK. And then our datum plane shows up in our feature tree over here. So to get a revolution going, we need to draw an axis. So we can select the datum plane, hit sketch. That takes us straight into sketching. Absolutely no plane specification required because we already had it selected. We're going to grab a line really quick. We're going to drop it down just like that. And then let's say we want to know how far this distance is, like how far the inner diameter is going to be. I can come in here. I can do include construction. So this is going to make a construction line that will disappear outside the sketch. I also want this to disappear outside the sketch because it's hanging out in the middle of nowhere. So I'm going to right click, go to this option that says convert to reference, and I now have construction geometry out here that goes away when I close this. So this isn't fully defined yet. It's not fully defined in terms of length, which is 9.8. But since this isn't going to define a part, we just need to have this be vertical and a certain distance away from here. So this is a sort of rare case where the length of this doesn't matter. This can just hang out. There's no reason for this to be any specific length at this point. So we don't need a length dimension. We can save ourselves that. But we come over here. We want to specify this diameter. Let's say we want 8 inches as that internal radius, because we're going to revolve around this. So that's an 8-inch radius to the center line of revolution. And we can hit finish. And it disappeared. So we're going to have a problem. And the problem is I spoke too soon. When we go to revolve, it's going to ask us to pick an axis, but the axis is gone. So we do have to show this axis, and it's no big deal. We go in here, we click Convert from Reference, the same button we pressed earlier, and we get our line back. And now when we close this, we can pick that as our axis of rotation once we're in the revolution menu. So if that ever happens, you hide something as a construction line you didn't mean to, just go back in, right-click it, and you should be able to convert back to a solid contour line like this instead of a construction line. So we're going to go to Revolve. It's going to ask us to pick a curve. And by curve, they don't want a solid body. Like, we're not going to spin this block around and make a pattern of it, because it would be very chunky and it wouldn't be quite right. So what we're going to do right now is we're going to hide everything. And like I said before, we want that sketch. I want to go back to that original sketch, and this is the curve that the Revolve tool is asking for. Because if I had hidden this inside of an extrusion, I can't access this as easily. So if you need that original geometry that I do now, that's the perk of keeping your sketches non-consumed by your features. If, let's say we want the scale body, if we do want this, which I don't have a sketch for right now, I only have that original sketch, which could be useful. You can come over here, you can say face edges, and you can click on that face, and it will take all of these and find the edges and give you something that is revolvable around this axis. And then for the axis, it says specify vector and a point, but since we drew our own axis of revolution, we can click on that. It gives us a preview of what's about to do. You can set the angle, so I can go 180 degrees around. I can start at 90 and terminate at 180. This is just like the extrusion distance rules we talked about before. But let's go 0 to 360. The Boolean is none, because I don't want to unite it with that block we had earlier. I want something totally standalone, so we're not uniting. We'll hit OK. I'm going to hide that solid body we had before by hiding the scale body. And then we have our revolve shape. And at this point, we want to check, do we have the internal channels? Like, we can't see if they're there. We have no idea if those that heptagonal and circular channel made it in here. So what you can do, again on my roll, or you can search in the command toolbar up here, is you can press New Section. It's going to ask you for a section name. So section 1 is A-OK. It asks you to specify a plane, which you can do by either dragging and dropping, so you can actually cut your part in half, or not in half, but you can cut your part anywhere. You can rotate this, you can tip this, you can do all kinds of stuff with this custom plane. But considering we had a plane already, that would be really good for doing some inspection of the internal of this revolution. We can just go up to specify plane, click our datum plane over here, and it snaps that cut directly onto our datum plane that we made. And then let me just correct this tilt I put in it to show off. Maybe not. Anyhow, we're on the correct plane. It's a little wonky. Our cut's at a little bit of an angle, but that's okay. And then you can offset away. So from that plane, which is the 0 point, which is exactly where we drew the datum plane, right in the middle, you can scoot your offset backwards and forwards if you want to vary the view a little bit. I'm going to leave that at 0 and hit OK. So now Up here, right next to new section, we can clip the section on and off, and we can look at that section view, and we can admire the beauty of those revolved heptagonal channels. And that will give you a good internal view of your part. And you can extend this to assemblies and manufacturing operations. Like in manufacturing, when you program for a lathe, you work in this view. In assemblies, you might want to see like a cross-section of how mechanisms work or how an engine goes together. So this same technique can be applied to all objects in assembly or all objects in a manufacturing setup, but we will get there much, much later. So that is everything I have for this tutorial. I know it's been a bit of a marathon, and I greatly appreciate you sticking with it. But this is some of the most in-depth fundamentals you will need to be successful in NX modeling. I do hope it was successful, and I'll see you in the next one. I knew I forgot something. There's one cool thing we can do in this that will really help you keep your mind straight and your vision straight when it comes to different features and different parts in assembly. So what I'm going to do is I'm going to turn off this revolve. I'm going to go back to our scale body here with all these fillets and chamfers and stuff. And I want to show you assign feature color versus edit object display. So what assign feature color does when we go in here is it asks for features to color. So let's say we want the circular channel that we put in there and the heptagonal channel to be blue, and we want the rest of this part to be red. Just to keep things separate, just to maybe show a customer or a stakeholder two different features, whatever the case may be. So I can come over here, I can pick the extrusion feature from the tree. I can specify color, and let's make that color, let's make those channels red, like I said. I can hit apply. So now, those features are colored red. If I do the same thing, if I assign feature color to the extrusion, the original extrusion, and I specify this to be blue, it will keep the original extrusion blue, but since we put in the chamfers and edge blends, oops. So this is what it was before the chamfers and edge blends, but as we add them, these features do not have an assigned color, so they go back to the default gray. In that case, I can click on edge blend, I can hold shift while I also click on chamfer to select multiple. On Windows and Mac, if you do control click, you can select multiple across a range, but if I do shift click, it will select everything in that range. Just a quick tip. So if I want to pick two at once, I can do shift to get everything in that range. Assign feature color, I want to specify these. Let's do lime green, hit apply, and then we can see where those edge breaks are on the part. So that's feature colors. Let's say this is about to go in an assembly, and we want this whole thing to be one single color so we can see it better. We don't want this, rainbow view. We don't want these multiple garish colors. We want to have this all deep purple or something, just so we can pick it out of an assembly, because the assembly might be really complicated. If you go to Edit Object Display, this is asked for an object, and a solid body is an object. So I'm going to pick the entire solid body. I'm going to hit OK. And then you have so many options in here where you can modify line styles, how it's represented on your 3D viewer, the width of lines. You can make this translucent, so we can make it fade away a little bit. And then we can set the whole thing to one color. So if we set the whole thing to deep purple, we make it a little bit translucent, we hit apply. Now all of the previous colors are gone, so we lost the feature by feature coloring, but the entire solid body has now adopted this purple hue. So this is really useful, not only for seeing through it, kind of like making it out of glass or transparent plastic, just to be able to see a little bit better, but it's also really useful to do color-coded parts in your assemblies to give yourself a lot more logical and visual clarity about what you're doing and how you're doing it. Last thing, while we're here, I want to do a very, very quick sketch. I'm going to throw it on the bottom of this part. I'm going to put in a rectangle. I'm not even going to bother constraining this because you can extrude these without being constrained or without being fully defined. I just want to show you something. So if I come over here and I want to extrude this, I want to specify the vector to go perpendicular to this plane. Let's go the other way. I can say until selected, and then I can say extrude up to that surface. And we see that it doesn't completely intersect the body, so it's giving me an alert down here. So I can do until extended, extrude up to that, and it extends the thing I've selected, and it's basically going to chop this off at this angle because it's extending this plane I've selected. It's extruding until extended. So once it hits this virtual plane over here, it stops and it no longer continues up to the tippy top surface. That's if we're doing subtracting. So it's trying to put a square hole in this. If we were to do a none, this is merging a solid body into another solid body. So right now, these are two separate objects. Like if I do edit object display and I hide this, I can still pick this object independently from the purple object. I can come in here and I can make this like hunter green. So those are two totally separate objects. They have nothing to do with one another besides the fact that they phase through reality and exist in the same 3D solid space. So just wanted to show that from this point I can unite them. So the target is this, the thing that's going to absorb the other object. The tool is going to be that, and I hit OK. And then all of a sudden, it has merged completely. So because it was already totally in here, it just disappeared out of existence when it got united. But you can unite like that. Let's say this is sticking off the edge as its own body. You can come in here. Let me extrude that really quick. We're going to do none. Oops. So these are two independent bodies, but if I unite them, we see that this has merged into that because it adopted the purple. On the flip side, if I want to subtract out the green body from the purple instead of just merging it into it, I would do subtract. Target body is the purple. The tool used to cut is the green. And so now we actually have a hole in this because I subtracted out the green solid body from the purple solid body. So that's just to show that when you do none, they are solid bodies that can merge into each other. But from there, you can either move them, so you can move objects into each other and then unite or subtract. Or, just like with this peg, you can do none to get this peg sticking off the side, and then go into unite to make them one single connected body. Either way, that is something you'll definitely run into, whether it's manufacturing, assemblies, modeling, whatever. I want to show that along with the colors really quick. I hope this was helpful, and now I'll see you in the next one.